Good evening, class, and welcome to our class today. Um, so today we are going to discuss about this analysis toolpack. In our previous lesson, we did discuss about the NPV, XNPV. So I checked on most of your assignments. Most people have actually got it right. But the question about the cash flow, that is where there is a problem. That is, you'll get the right format, but sometimes the format, you missed some values, you missed some basic concept that need to be added in that format. So I was preferring that we have a discussion on that question. In our next lesson, we are going to go through that question about cash flow. So we have to discuss that cash flow point by point. That is every point, so that at least you get the concept that sometimes the format I gave you previously need to have some added added concepts there. You need to add more tools. So you'll discuss it as cash flow in general. That is what is required from you in general to have the cash flow. So basically, I did enter the right format, so though I have not taken in the data, but I'm very sure that once I key in the data, then it will be able to get the right values, be able to get able to balance off that cash flow. So just briefly, I want to show you the format that I have, so that in case you can add to your free time, just add on your format, then you'll be able to solve the same problem. Maybe even before Saturday, you can have it, we can discuss now together. So just a minute, when we share that, then you'll get to see the format I'm talking about. So just a minute. So, though we're not finished tackling the question, but some of the tools that you need to add, like we have, this is the format of the cash flow that you need to have. That is, in your cash flow, you need to include these. After profit before tax, there are several adjustments, like the gain of on a financial asset, the financing cost is given, the amortization of intangible was also provided, but most of you did not include those things. That's why it failed to balance off. But the format was right, only that you missed some values. So let's discuss this one in our next lesson. Then I'll be able to get that one right. Then there's another question that also people that you attempted, but there was a small challenge. This was question number 23. The question was asking about the IRR and the IRR, and some of you actually achieved this. They achieved up to this point, but they never gave out the section number 2. That is, you are to explain why you are actually to highlight the cause of the difference between NPV and XNPV. Explain which of these would be used in analysis and the reason why. So that one, most of you actually did. They achieved the right answer, but they never explained. The project was actually viable. Why? Because the NPV was a positive value and it was not 0. So the project was actually viable. But the two were different, and the cause of difference is the dates. That the dates in some of these dates, if you check, you can even check here. If you have to use a simple function like days 360, then you find that the difference between the first date and the second date, that is this date here, is roughly not even 1 year. If you check again the difference, if you use the days 360 is a function that we use to check the number of days between the two dates. So you'll find again the date between this and the next date are also different. So that means this is almost an year, this is almost half, not even half the year. So that there was a difference between the dates, and that's what caused the difference between these two. That in XNPV, it considers that discounts of the dates or the period that were less than an year, and it caused the difference. So we say the XNPV give us a clear picture of how this project, whether the project is viable or not, because it considers dates. So the same case you have to explain under this. So if you did this and you failed to do this Roman 2 or B Roman 2, then you missed 8 marks. So you had to do that to get those full marks. So today, if you check on question number 25, of course, not computed. I had computed some values here, but now let me remove those values. The question was about a regression analysis. This is something you did in quantitative analysis in your foundation level. And here is also tested. It's actually one of the application areas of data analytics. So you are supposed to compute to determine the variable cost per unit and the total variable cost using the regression analysis. So this is what we are going to discuss today. Is our next topic. Our next topic, I hope I've shared there, and I will share this book in that content. The book is a bit lengthy, but we will start from the beginning because we don't know what will be tested. We have several statistical analysis tools that we use to run statistics. Where regression is one of them, and we have others like the correlation, we have the t-test, the f-test, the chi-square. All these are tools that we use in analysis. So in Excel specifically, we have the analysis tool pack. And this is what will help you to run this analysis. And we'll start with how do we activate the analysis tool pack if your machine is not configured to this. Some of these functions you cannot run them if you have not configured your Excel to capture this. So I prefer we use the Excel, a higher version, that you'll be able to capture this one better. And we're going to use this Excel 2013. If you're using 2010, you can also capture the same. And to activate the analysis toolpack, when you click on the data tab, you can click there, data tab. Then you realize that under this data tab, we have a number of tools here. But towards the end, we are supposed to add 2 extra tools. That is extra tools towards the end of this. That is here under the data tab. After the outline, this is where we add the data analysis. So how do you activate this? You click on File, then you select Options. Then from Options dialog box, there is that option for selecting the add-ins. And once you choose add-ins, then it's supposed to produce several active add-ins and those add-ins that are not active. So you need to check whether you have those add-ins Sometimes it really change the language, but I believe the analysis toolpack, you see somewhere written analysis toolpack, and you open that analysis toolpack. If I'm using the other Office version, you'll see it. That is, you click on File Options, then you select Add-ins. So, and you'll get I've already activated the analysis toolpack. If it's not activated, you select it. Then down here, you click Go. Supposed to produce this dialog box. Let me repeat. Let me repeat. That is, if you're using a higher Office format, again, you click on File, you select Options. Then you click on Add-ins, Add-ins. And there under Add-ins, you'll find somewhere written Analysis Toolpack. Under Inactive Application. Mine is here, it was changed, the language was a bit changed. Then, when you select that option, then down here, Manage Excel Add-ins, you click Go. Supposed to produce this simple dialog box. Then you activate the analysis toolpack, both the VBA and the solvers. You don't need the Euro tools, just activate those three, then click OK. So once you do that, it will activate that option, and you realize that it has added this tool here called analysis. It has data analysis and it has solvers. Those are the two options that will be added in that tool. So each of them is used to solve a particular task. Like the data analysis tool uses tools for financial and scientific data analysis. And the second one, solvers, is under the HOTIV analysis tool that will help you to find the optimal value of a target cell by changing the values of cells used to calculate the target. So you remember when you are doing when you're performing these tasks about data tables during the scenario analysis, then we found that we have only two inputs, that is the row input and the column input. But if you have more than two inputs, then you cannot go using data tables. Then the only option you will go for is to use the solvers. So we have activated this data analysis tool. And now from here, we'll be able now to compute our analysis. So you don't have to master those formulas that you did in your foundation level again. So you require to have the idea of how to come up with either of these. Like for example, you need to know the function of each of these analyses. If it is regression analysis, we know very well that we use this analysis to project, like the way you are given that question. Suppose you are given a specific sales of this much, then how much are you going to sell, or how much are you going to get as a cost after a particular period of time? So you just need to know the equation that you use, the equation of the straight line. And once you do this, then you'll be able to compute your work. So we'll start with a simple analysis, and we'll start with running a simple histogram. For example, a histogram. Once you activate, so I'm activating the analysis toolpack, click on the File tab, click Option, go to Add-ins, then activate this, and you'll find that analysis toolpack. You select the analysis toolpack, and now come active. Where do you get it? You get it on the Data tab. So now I want to share. Yours is not working. Kindly share the book. I'm going to share the book. So I'm going to share the data first, the data that you're going to use to run this, and you start with the first data, so that you help us to compute the histogram. You know, when you're using these applications like the Office version, the lower version, and inserting the charts, the option of this histogram is not present in the lower versions. So you click on Insert, then Charts. You'll find that if you're using a lower version, like here, we don't have histogram. We don't have a histogram. But The question is asking that you should give a histogram. So then how do you achieve that? And still using the same program. So you, in data analysis, then you have to include those data analysis tools. And I'm sharing the data. I hope you have seen it. Let me share that data in the platform, that is the Zoom platform. You get it from there. So no sound on your end is a problem in your machine. So just confirm. You can add the sound level to the sound level, or you can adjust the sound level. So I've sent the copy. I've sent that copy in that platform. I'm sending another copy in the group, WhatsApp group, so you can also download from there. Is it computed? Just a minute. As was already computed, we don't want the computed data. So you can disregard that data. Just disregard the data. It's already computed. Now download that one now. That is okay now. Just download that. So connected in WhatsApp group. Again, you can also download from WhatsApp group. So once you get the data, you can confirm that you have the data. Just confirm that you have got the data. And this data will be something like this. So we are given some values here, the rate, the number, that is some values about the students, the number of students. This is a population of students. And the data was about just population of students, nothing much. And you are given some frequency here that is supposed to help us compute the histogram. So once you compute this, then you are supposed to run that histogram. Remember that we said we are using this program, there is no way you get the histogram. So how do you set this data? So when you are working with these data tools, all the tools for data analysis, including the R, SPSS, Excel, the Jamovi, and all those tools that we use in data analysis. they use the same principle. That first you have to access the tool. That is, you click on data, then you select data analysis. So I hope you are there. And it's supposed to produce a data analysis toolbox. And this toolbox will give us several data analysis measures that you can use. We have the descriptive analysis. What we want to form is just a simple histogram to explain how this data analysis is supposed to, and how you should present your work. So once you select histogram, you click OK. So it will ask you to enter in the input. So it is divided into two. First, you have to present the input, then you present the output. So where is the input? The input is in the range of cells that contains our data. So you select these cells from here up to here. That is our input. Then the bin is supposed to give us the frequency. That the frequency of this, that is, these are the frequencies that are given. So what does this one mean? That it means simply, it means a simple meaning that in this range of cells, the values between 0 up to 20, we want to know the frequency of the values between 0 to 20. The frequencies of value between 21 up to 25, and so on. So once you select the range of data, you're supposed to present your output. So where do we set our output? So you select output. We are supposed to present our output in a specific range of cells, where you just click to set where to set your worksheet. So you want to give out our output somewhere here. This output should include what? It should include a chart, that is now the histogram, and you can also select all the others. Then finally, you'll click OK. So once you do that, then the Excel will do its magics, and it is able to compute, create a histogram, and it will give you the frequencies from our data, that the values between 0, the values between 0 to 20, how many are they? From this data you can check, you'll find it is only one. The values from 20, that is from 21 up to 25. So you can even count them. You have 22, 1, you have this one, you have this one, you have this one, and this one here. So they are around 8 values. So meaning that is able to give you the right frequency, the chart of frequency against this bin. Here we have, it will give us a simple histogram, and you can see them that you don't have to run those formulas and take a lot of time just to produce a simple histogram. So in case you want to remove this legend because it's not much important, just like other charts, you can deactivate that legend. You can say you don't need the legend, and you have that data there. You can resize this histogram like that. So that is simply how you run this analysis. Someone is saying we repeat. Mine does not have a chart. Why? Because it did not select the chart. So it cannot fail picking the values. Let's repeat just the last minute. You can repeat this. Just remove these values from here, and we repeat the process again. You don't have to select any data. Just click on any cell, and from there you select data. Select data analysis. Choose histogram, and then click OK. To only ask you two things. One, the input data and the output results. The input data, the first input data is the range of cells where the range of population is populated. So that is from A2 up to A19. Then the bin is this data that will help us to generate the frequency. Then from there, you're supposed to select where your output data will be presented. You just select the first cell where this data will be, where the results will be computed. You can even have it in the new worksheet or in a new worksheet or in a new workbook. You want to have it in a new worksheet, then you select new worksheet. If you want to have it in the same worksheet, then you have to choose the cell where this data will be placed. Then down here, you have to select chart output. And once you do this, you click OK, then automatically it produces that chart. And with the various very accurate analysis that will help you to analyze your work. So that is just a simple illustration of how this data analysis tool works. So we can proceed to the next level of this data analysis. Now you move to descriptive analysis. And here, you're going to check when you are given a piece of data, you are told to get the descriptive analysis. Descriptive analysis, which means the measure of central tendency, the measure of dispersion, the measure of skewness, kurtosis. If you are given this is the data that you're going to use. So the descriptive analysis, you can use it to run all those descriptive analysis tools. And these descriptive analysis tools will include the measures that you have you discussed there previously. That when given a piece of data, like here we have the scores of 14 participants for a test. The scores for 14 participants for a test. And we have this data provided. Then you are supposed to run all the descriptive analysis. I'm sharing this data. So once I share the data, you download the data, and then we are going to run that analysis together. Remember that this tool pack is a little bit wide, so you have to be fast. You have to be a little bit fast because we also need to cover the syllabus on time. So we have to be a bit fast. You can ask any question in case you have a problem. I'll repeat some of those tasks. But the chart, if you're not getting the chart, the simple reason is that you did not activate that chart option under the output. So you just activate that option to produce the chart. So I'm sending that worksheet. So you can download it. So just get the worksheet. I'll send it, download the worksheet. Then in WhatsApp, I'm sending another copy there. So you just download that worksheet, open the worksheet. Then there's Fine, fine, you have rectified the sound. Sorry for that simple interruption. Then, okay, we are running this descriptive analysis. We said that the first step, you click on data, then select data analysis. From here, you choose data descriptive statistics, then click OK. You have to specify the input. Why is our input? You select the range of cells that has our input. Then remember that in case you choose the first cell, that is, when selecting this range of cells, just check here that I select from the score. If I select from the word score, then downward, then if I use this cell, you know this cell has text instead of value, I have to indicate that labels in the first row so that it will not use that cell to compute our calculation. So then once you do this, you have to produce out the output. Where is the output? Where do you put our output? Our output, you have to select the cell where this output will be pasted. So that is from cell, I can start from cell C1. Then it will start from there downward. Then together with that, I need to have a number of analysis. Under the descriptive analysis, we said it helps us to produce several analyses, especially the measure of central tendency, the measure of dispersion, the measure of skewness. It will help us also to create that confidence level of a specific percentage. So if you select summary statistics, then you can set the confidence level maybe at 95%. And from there, you click. You can also set the kth largest and kth. That is what we call the quartile and that is the quartiles and percentile. So once you select this, then you click OK. You don't have to enter any formula, but Excel automatically compute those values automatically. It will help you to get the mean, the median, the standard deviation, to help you to get the kurtosis, the skewness, to get the sum, the count, the number of, then the confidence level at this level here. And it will give you those analysis just automatically. So it makes your work so easy and very, very accurate that you don't have to make errors when you're running such simple descriptive analysis. So I hope that one is very, very clear. So please confirm that you have done it so that we proceed to the next function. So as I prepare the next data, so do we need to round the numbers? No, we don't have to. Because the numbers that you have got here shows the level of accuracy. So the numbers here is a bit different from the numbers you have been receiving maybe in the previous exercises, because this number itself, you know, if you get the square root, the variance, the square root, if you multiply that number, you know, to get the square, the standard deviation and the variance, they somehow related. That one is the square root of the other. That is, if you want to get the variance, then you can say that this number multiplied by the same number. Whatever you get here is here. So, and the reason why we are getting this is because of that degree of accuracy. So you don't have to round off to just leave it those number of decimal places. Then I'm repeating for the last time. Repeating for the last time for the sake of those people who are saying we repeat. And please, you have to be keen. Huh? Yes, we said that if you want to run any analysis, no formula is required here. So what you need to know is where is your data and where is your output? Where do you prefer to set your output? What is required for this? So we said that first you click on the data. This is the simplest thing you can do actually. Once you click on data, you select data analysis, and then you choose descriptive. That is what you are looking for. The descriptive analysis, the descriptive statistics. Then you click OK. Once you select OK, you have to highlight the data. To highlight the data, the input, you have to set input. We have the input range and we have the output options. The input range, the first thing is to set up the input. Input, where is our input? Then our input is from here, downward, all the way to here. That is the cells that contains our data. But the first row has the label. So you have to indicate that there is a label in the first row. Then the output, if you don't indicate there is a label in the first row, it will probably give you no results because that will affect the data. Then you have to select the output. Where is our output? Our output probably start from a cell here. So you just indicate where this output is to be posted. Then finally, you need to include the summary of what you want to present. If you don't activate the summaries, then you not get anything because it's these summaries that you want to produce. Then finally, you click OK. The interpretation of this one need you to have or to have already understood that all these measures and what they stand for. That is something that you did, went through this, and you're able to explain every measure and what you can get from them. So that is how you run that analysis, and that is the descriptive analysis. Then our next discussion, we're going to check on something we call the analysis of variance. Analysis of variance. Analysis of variance is another tool, another measure that we use in descriptive statistics. But now here, there is something that you need to understand, that before you run the analysis of variance, the F-test, the T-test, the regression, and the correlation analysis, you must have set the hypothesis. You must set the hypothesis. So, and we say that hypothesis is actually a theory that probably that is proven to be true, or maybe not necessarily true, but it forms the base of argument. And we are going to check on this, that the first thing you need to understand is how do you set the hypothesis. One thing we know about the analysis of variance is that this is a measure that will help us to compare the means, the means of different variables. That is something that you did in your foundation, that you are given the means, you're supposed to compare the means. Then you can use this analysis to check whether the means are the same or are different. So we'll start first by discussing what is a hypothesis and how you can set up a hypothesis. So just a minute, I share something here. So, hypothesis. I have these, just a minute, I want to check about this. Now, hypothesis, yes. That we say a hypothesis represent, the null hypothesis represent a theory that has been presented for what reason. Either it is believed to be true or because it is used on base as a basis of argument. So you need to say that hypothesis first. Is a statement that has not been proven. So we are using this data to prove whether the base of argument will be either true or false. So this null hypothesis is a very important, it's also important to realize that the null hypothesis is a statement of no difference. No difference. No difference. That is, you should know the null means no, no difference. That is, for example, sometimes given a situation like we have a drug, a new drug, the old drug. You are supposed to compare between the two drugs. Then you say that the two drugs don't have any difference. The new drug and the old drug exhibit the same characteristics. Then you can say there is no difference between the two drugs. The alternative, then it will be stated that there is a significant difference between the two drugs. So you have to set the hypothesis first. And once you set the hypothesis, then a special consideration will be laid down that after running your data, do you accept or reject the null hypothesis? That is whatever you get from the output, then you have to base your argument from that. Okay, well, the special consideration is given to the null hypothesis. That is due to the fact that the null hypothesis relates to the statement being tested. And whereas the alternative hypothesis relates to the statement to be accepted if and when the null hypothesis is rejected. So you have to consider when do you accept and when do you reject the null hypothesis. Now with the data, have I shared the data? Let me share that data. We're going to use a simple data first, then later we're going to engage with other data, that is other complex worksheets. So let me have this data. So you can download that data, send another copy in WhatsApp. Then you open that data. So there was this piece of information about these specific details here. And once we have seen that the analysis of variance is normally used to test the means. So below, you have several findings that you can find the salaries of people who have several qualifications in these areas, economics, medicine, and history. Then you are told to get, is there any difference between these salary rates of these people? So if you are to set the hypothesis, then you set the hypothesis. The null hypothesis, you say that there is no difference between the means. That is the null hypothesis, that the three of them have equal means. The mean of 1 is equal to the mean of 2 and equal to the mean of 3. Then the alternative, you say that at least one of these means is different, or 2. So you have at least one is different, or all of them are different. So that is how you start, by setting up the null hypothesis. Then you are going to run the data, and whatever you get from the data, then use this data as the base of argument. So How do you include this? You click on the data. You click on the data. Then from there you select data analysis, data analysis. So what are you looking for? For now, you're only using a single factor or the single factor analysis of variance because we have a small piece of data. I've already sent the data in WhatsApp. So you should download the data and have it in your machine. So once I select single factor, then I will click OK. You ask me to put the input. Where is the input data? Then I will select my input data ranging from here all the way from cell A1 up to cell C10. That is my input data. And considering that here, the label in the first row, that in the first row, it presents what? It represents the labels will not be included in our analysis. Then our output, where is the output option, the output range? Then here you specify the cell where you place your output. So I'm preferring to place my output from cell output from this cell A1, E1. Yeah? Then I just click there. And from there, the output will be retrieved. And finally, I'll click OK. So once you do this, then Excel will just do its magics. And it will give you first the groups here, the two tables, the summary table, and it will also give us the analysis of variance table. So the summary table that shows the number of counts, that is how many people under this category. We have 9, here you have 7, here you have 9. Then the sum, it will give you the sum of those values. Then it's able to get the average of the same values and the variance of the same values. But notice that it has not computed the mean. And remember that in analysis of variance, it's all about comparison of the mean. So how do you run your conclusion? One thing very simple, that first, you need to highlight your hypothesis. You have to set the hypothesis because the hypothesis will help us run our conclusion. So the hypothesis test first states that there is no difference between the mean and there is a significant difference between the means of those three variables. So you have not stated the conclusion, but the conclusion should be based on the F and the F critic, the F and the F critic. And we're going to use that to base our argument. So how is our argument? Then we say this, that when F is greater than F critic, then we reject the null hypothesis. That is how you run this. So you'll get this as the results. And after running the hypothesis test, where we have stated that H0, there is no difference. Here, there is a difference between the means. Then how do you conclude? Then the conclusion will be written down here. And the conclusion is based on F and F critic. We have said that if the value of F is greater than the F critical, then we reject the null hypothesis. The value of F was 15.196, which is greater than 3.443. Therefore, we reject the null hypothesis. This means the three populations are not equal. They are not equal. That is, at least one of the mean is different. That is, the ANOVA will not tell you where the difference lies, but it will help you to identify that there is the difference between the mean, that these three populations are not equal. They are not equal. So that is how you run these analysis. So I hope that one is clear. I hope you have done that one already. So that is, you write your conclusion there based on what you have got. And this will be our conclusion. This will be our conclusion. So just one more time, I've stated there. So we never had this. And if you are to use the formulas to compute this, it will take a lot of time. It will take actually a lot of time to finish a simple analysis. That to compare the means. The formula of getting the mean, you know, the summation of x divided by fx. You know that you get the mean of this, you get the mean of this, you get the mean of this. Then you compare those means. And once you do that, you know whether the means are relating or they are the same or not. But instead, we can use the power of Excel, the power of Excel to help you compute this. And we stated that it is not magic. It is not mastering of any formula. It's just selecting the right data. That is, you just click on the data, select data analysis, and then you choose the right tool that you're using right now. You have a simple data, you're going to use the simple factor. We can also use others that you're going to see later. The ANOVA two-factor with replication, where data is replicating. That is, we have duplicates of data. And where we don't have duplicates, you can use this. But our data is simple. We are going to use just single factor. And you click OK. Then from there, you have to specify where is your input data in a specific range of cells. That is from this cell to this cell, you select the range of. Remember that the missing data still used in analysis. It means a lot. So that is, when you are running the questionnaire, you don't disregard the questionnaire because it was not filled. Because sometimes the respondent may not feel something because probably it will not apply in his case, or he did not understand the question. And those missing values also makes our data more accurate. That way we have to highlight even those missing values. Then from there, you have to include the label in the first row. That is, we have labels in the first row. That though we have selected the first row, but this row should not be included in our statistics. Then finally, you have to produce the output. Where do you put our output? Then here you just specify the cell where the output will be presented. And then finally you click OK. You are not doing anything. Your work is just to select the right range of cells, give the right input, and present this data in the right place. And once you do this, Excel will compute these values. Don't ask where these values are coming from. We don't have any formula. Excel will just compute the values automatically. And once you get the values, then your work is to do what? Is to set the hypothesis. That is all what you need to do. You set the hypothesis, the null hypothesis, and you set the alternative. Once you set the hypothesis, then finally you make the conclusion based on the data you have got here, that you are comparing these values you have got here, the F and the F critical. So later, as we run the F test, you see the value of F, which is a very important factor in the analysis of variance. So how do you set the hypothesis? We said that hypothesis is actually upon you. It is not something, it can even be different to different people. You can decide to have your own theory. But this theory, we said, it is not actually true. It does not necessarily mean it is true. It's only helping us to base our argument. And when you are setting up the hypothesis, then you have to set the two. The two hypotheses, one is the null hypothesis, and the other one is the alternative. And the null hypothesis stated is the statement of no difference. No difference. That, like in this case, there is no difference between the two drugs. Sometimes you can be asked to say the hypothesis. Is there any relationship between this, that is smoking of cigarettes, and the spread of cancer, lung cancer? Then you can say, is there any difference? Then if there is no difference, the null hypothesis, you say that there is no difference between these two. That is, there is no relationship. There is no any relationship between the two. Or you can say the alternative, that there is a significant relationship between the two. So it all depends on the data that you are given. And here, we set our hypothesis. Remember that if you don't have the hypothesis, then you'll not be able to conclude, because once you say that, you're supposed to compare the F and F critic. So comparing of this, there's another thing we call the p-value, which is the threshold. If you check, we have a p-value somewhere. The p-value was presented as a scientific number. But if you want to convert it into a real number, then what you need to do is to adjust the column width. You can also use the p-value, where we say that the threshold is 0.05. That if the p-value, remember that this scientific number sometimes can really confuse or give you a wrong output. You have to adjust this because this is a very small number. Small number, that is 0. If you check on the formula by, you actually see the number. It is 0.000007 something. That is a very small number. And you say that if the p-value is greater than, maybe I can share this one with you here. Let me share that one. Then you can see how you can also use the p-value again to analyze the same results. Just a minute. So we say that if the p-value, the p-value is less than the threshold, that is 0.005. We also reject the null hypothesis. We reject the null hypothesis. So the null hypothesis can be rejected in two factors. If the p-value is less than the threshold, that is 0.05, or if the F is greater than the F critic. Those are the two things that we use when deciding whether to accept or to reject the null hypothesis. Remember that the system has been set that way, that in case it gets that value, then our analysis will go either side. Either you accept or reject the null hypothesis. So, just a minute, I share this. Share something here. So let's see this. That after you run any analysis, there is that part of deciding the conclusion, making decision. And making decision here, it means that you have to decide. You have to decide based on the numbers you are given, that when the p-value is less than the 0.05, this is a given number, is a threshold that is given, then we always reject the null hypothesis. That is the same thing you are using there. That after testing is complete, the final conclusion is given in terms of the null hypothesis. The results is either reject the null in favor of the alternative, or do not reject the null. That conclusion is never reject the alternative in favor of the null hypothesis. It is never like that. It's only reject the null hypothesis in favor of the alternative. And once you do this, then you'll be able to compute your results. So in this case, you can use either two things. If the p-value is less than 0.05, of which if you check from our data, it is less than 0.05. We reject the null hypothesis. Or when the F is greater than the F critic, then we again reject the null hypothesis. And what do we say? That in this population, the mean of this population are not equal, So I think that one is clear, very clear. So our next discussion, I want to jump a little bit. And because in our case, you are given the question about the regression analysis, and you're going to check on this regression analysis. Then finally, you come to finish up with F-test and T-test, probably in our next lesson. So just allow me to just go up to this part. What is the regression and the correlation? Then because that one is actually involving, and you find that it has been tested several times. So, but we have to go through all of them because we don't know which questions we will bring in our next lesson. So you have to go through them. So let's move to this part of the regression analysis. And one thing you have that is we know about regression. Before you run regression analysis, it's always important to run the correlation analysis. And somewhere you are told that correlation actually helps us to determine the level of relationship. That is the degree of relationship, whether there is any relationship between variables or not. that you can run, or you can identify whether there is a relationship between variables or there is no relationship between the variables. That the correlation is actually a matrix in Excel that summarizes the correlation data in a tabular form. And it will display the correlation coefficient, which measures the relationship between two or more variables. So the correlation option of data analysis tab will help us to create that correlation matrix. The matrix, a set of numbers arranged in rows and columns. So the explanation of correlation is that correlation assesses the dependency of one variable on the other. It shows how the impact of an increase or the decrease in one variable affect the other. So in multiple correlation, more than two variables are studied at the same time, and it's able to give that relationship between the variables. If you get a positive correlation, then it implies that there is a positive relationship between the two variables, because correlation coefficient can be a positive number or a negative number, or it can also be a zero. A positive correlation, the correlation coefficient of positive, that is +1. It is from 1 + 1 to 0 to -1. Implies that the two variables move in the same direction. That is, it simply means that where the correlation is positive value, it indicates that there is a perfect association between the two variables. There is a perfect relationship between the two variables. That's what it means, that there is a perfect relationship between, if it is +1. If it is 0.5, probably negative, it indicates a moderate negative relationship between the two variables. You can use the Spearman on the or the Pearson rank correlation, whichever the format you use, always come up with the same solution. So that is one thing you need to understand about correlation coefficient. The negative correlation coefficient implies that the two variables move in the opposite direction. Zero correlation, this one indicates that that the two variables are not dependent on each other. That is, a change in one will not change the other. So the characteristics of correlation then, we'll get a number of them. That correlation shows the cause and effect relationship between the several factors. The closer the correlation coefficient to 1 or -1, the stronger the relationship between the variables. So if it is 0.5, it is moderate. 0.8, it is closer to very strong. It is strong. If it is 1, it is very strong. Then the presence of correlation coefficient does not indicate that there is a relationship between the variables, the presence. That is, sometimes other factors will also affect this. You'll see this one later when learning this correlation coefficient. And anytime in Excel you run this, it gives you a matrix, a number. And this matrix will read the matrix that will help us see whether there is a relationship between the variables. So remember that this is something that we can do, or we are going to run these together. So yeah, I'm going to share this data with you, and then we're going to share the file with you that you're going to run, and then you run it there, we do it together there. So let me get the data. We'll start with the correlation because it will help us to understand better the regression analysis. So I'll open the data about this. So select correlation. So here you are given a simple piece of data showing the variables A, B, and C. And you're supposed to run the matrix that shows those values. Then from the matrix, you can even make a small graph that shows the relationship between the variables. So that is one piece of data we can use. The other alternative is we can type the data that is in the book. It will help us to get this one better. So I would prefer we use that data in our books. We have the variables. Okay, to take time to type. Let me share this. Instead of having all that time, let me share this data. So, just delete this. So you can download it, just download there, send it in that Zoom platform. You can get it again in WhatsApp. Download that piece of data and then open it in your machine. So we are to run this. We run this one first together. Remember that we are doing this one. Then later you are supposed to run this one now at your free time. Some people are just complaining there. I don't know why they are complaining because we are actually doing it right now. And I've always done that. We share, we discuss, then I send you the copy. You go and do the exercise. So I will never send this one before because I know some people are very clever. They will get the notes, they will not attend the class. Then they will say they have everything that they want. Huh? Yeah. It is never like that. So you get the idea first. You get the concept first. Do it in your machine right now. Then when you get this one, you actually learn. This book has so many exercises. We are just doing one. Then at your free time, you'll go and now do the other exercises slowly at your free time. Check whether it is giving you the same results. Then you're going to do an exercise in the past paper. And once you do that, you send the assignment, then you are good to go. So that is the simplest way we can help each other. So let me run this. So I'll just open the worksheet. And in this simple worksheet, we are supposed to run this analysis. How do you run this analysis? That is actually the most important thing. It is not what is the notes, because these notes, I formulated them myself. It is assumes me that these notes are the only notes you can use. We have other notes, huh? We have other formats. Huh? So it's just a simple guide that you help you run this analysis. Can be done in other ways. But you want to see first, how do you run this? We said the process is simple. The process is very simple. That what you need is first to know which type of analysis are you running. In this case, you are running the correlation. And this correlation coefficient is actually an Excel function. It is something you run, is an Excel function. And it's something you can run in Excel. That is, if you insert the function, there is the function of correlation. That is, you can type the function correl. It's normally called the correl. The correlation. That function is actually an Excel function, which you can insert. It is an array. It actually shows the range of cells that you can highlight from. You can either highlight from the range of cells, you can use this function, or you can use the analysis toolpath. We want to see whether both will help us to get the same results, Huh? We want to see whether both of these will help us to get the same results. So just a minute, let me check on something here. So start. So you'll click on, we'll start with the data for using the data and the analysis toolpath. So you just click on the data tab. Then from there, you select data analysis. So what measure are we creating? We want to set up the correlation. You select correlation, then click OK. Then from there, you're supposed to select the input range. So where is our input range? The input range is actually the range of cells from where we'll be selecting the data from. So in this case, we have two range of cells. We have the two range of cells. We have from actually there are three, from A1 up to A2 up to A6, B2 up to, so you can select those range of cells. That is, you can highlight that range separated, or you can highlight all of them. Then indicate that the first column has what they have the labels. Then the output, going to say the output in this cell, and finally you click OK. You see what we have done? Let me repeat again that first you'll click on data tab, and from the data tab, these are our column headings. Not maybe they have, can change them a little bit. Instead of A, say Z, X, Y. So we are using those variables that we have the variable X, we have the variable X and Y. So, and we want to compare these three variables with the data that is presented. So you click on data, then from the data, you click on what? The data analysis. Then from here, you select correlation. Once you choose correlation, then you click OK. You set the input. Where is our input? The input value is the range of cells that contain our data. That is from cell A1 up to cell C6. Then from there, you have to indicate that the first row contains the labels. So indicate that it contains the labels because the data that is provided here is in form of text. Why is our output? You set our output. At this cell, you're going to set our output, then click OK. So what will happen is that it will give us a matrix. The matrix you see that X, have that matrix X here, the X again, that is the Z. We have the X and we have the Y. So what do we get here? That the correlation, if you are to use the formula, let's use the formula again to see whether the correlation will give us the value of 1, where the two values intersect. We get our correlation coefficient. So let's see whether it will give us again the value of 1. If you are to use this formula, then you will insert that formula correlation and you choose the first array. I want to choose the first array that the values from A2 up to this. That is the first array. The second array, again, the values between this. And the third array, the values between this. And finally, you close the bracket. Then press enter. Just a minute. I have too many arguments. Too many arguments. Supposed to have just 2 arrays. And then let's press enter. So it will give us a value. We have got this value that is 0. You can get our correlation is 0.1. 0.1. The correlation is 0.1. So that is the value you have got. So let's see that once you run this, the value that you get after running that analysis. Let's check from the summary part. Summary, where is the summary part of it? Just a minute, looking for that particular point. So this is the detail that we are running, and we are given those values. We also run this a different exercise. We are given 2 values, that is the X and Y. And if you insert the formula, here it gave us -1. In our case, the formula has given us a correlation coefficient of this between these 2 variables. And suppose to take only 2 variables, relating the 2 variables. Yeah, and you'll get the results. And from the results, then you can interpret the data. Interpret that data. So let's see the interpretation of our data that you get from this analysis. So our data is this one here. We are running those variables. I'll just change the name to X, Y, Z because of conflict between these column headings. So that is this, our data was initially like this, A, B, and C. And once we run the analysis, how do you run the analysis? You say that you click on data, you select data analysis, you select correlation, then you click OK. Set the input, and you set the output, then you click OK to give us this. So, and once you get this, you need to conclude this. You have to give a conclusion. So how do you conclude? Without even having to set the graph, you realize something, that the conclusion of our analysis is that the variables A and B positively correlate at this point of 0.91. 0.91. That is A and C correlate at that point. Variable A and B are not correlated. They are not correlated. A and B, A and B. If you check A and B, you have 0. A and B, we have 0. You can see that one. So A and B And if you check even the other way around, that is, okay, A and B have here a 0.19. That is what you get here. So the variable B and C also are not correlated at this point. That is to give us a value of 0.1. That is the value you have got here. Then you can verify that this conclusion by look of the graph. If you check the graph, you always give us the correct argument. That how is the graph? When these values are correlating, how will this graph flow? The values will not collide anywhere. Those lines will not collide anywhere. They remove at a linear motion. That is without colliding. That the change of one changes the other. But if you are to give this, if you are to create the chart from our data, it means we highlight the data. We highlight this data. After getting the conclusion, we highlight this data this way. That is, we want to compare between these A, B, and C. You can highlight the data and then insert a line chart. A line chart. You can use any line chart. Okay, that one, I think I've selected the wrong. So we need to highlight the data either vertical wise or horizontal wise. But the best way is to highlight the data in this nature. And okay, just a minute. Just a minute. So where do you get the chart? Actually, it's not from our array. It's not from our array. We create the chart from our data here. That is, if you are to select this data, because that is our actual data, then you insert. You can insert either a line chart or a bar chart, whichever type of chart, but mostly we use the line chart. Or you can use, the line chart is actually the most accurate here, and you get the line chart of this nature. Notice that in this line chart, this graph is not moving at a linear motion. There is no any of this line, none of this line that is moving at a linear way. That is it's not moving in a linear way. So the change in one variable is not specifically positively the change in the other variable. Why? Because the correlation coefficient did not give us one. Did not give us one. That way it is like so. So that is the correlation. And this correlation, first, we help us to determine whether there is a relationship between variables. So I want us to use a different data set, and we can actually check with this from an exercise that was here, that you are given this data about the musical ability versus the mathematical scores. And we want to see whether there is any relationship between the two. With this data, then we can run a simple correlation that will help us to see whether there is that relationship. How do you input the data? So inputting this data could be done either in row format or in column format. But the best way to input the data is in column format. And with this, then you can have this data. That is, I will type here the music score. And I'll type the maths score. Then what did these cause? These scores were like this. I'll just type them moving down. You have here 2, 6, you have 4, you have 5, you have 7, you have 2, 3, you have 5, and finally we have 4. Then the math scores start with 8. Then you have 3, 9, 7, 2, 3, 9, 8, 6, 7. So those are two data sets. If you check that at this time, when the score of music is this, the score of mathematics is this. When the score of music is this, the score of mathematics is this. Now we are told, is there any relationship between this, that is the musical ability, and the mathematical ability? Then, to run this analysis, there are two ways you can use. First, you can check the correlation coefficient using that correlation function, which is a function you insert. It will ask you the array. The first array is this, then comma, and the second array is this. Now, once you do this, you press enter. It will give us a negative value. That shows there is actually a relationship between these two variables, but it is a negative relationship. That simply means that those tend to have the music ability you have will tend not to have the mathematical ability. That's simply what it means. If we are to use the analysis toolpath, then again you click on the data, then you select this correlation, then again you select the two set of data. Where is our data? Then again you have to select the input, that our values are in these cells, whereby the first row has what? It has those values. Then where is our output? You have to indicate our output. So we can set our output somewhere. We press this. We can set our output somewhere here. Then you click OK. And you'll find that that correlation coefficient here is giving us this value, the same value here. So that will help us to determine the correlation coefficient, meaning that if you are to make a chart, if you are to create a chart, usually there is the chart we call the scatter chart. You can use the scatter chart to notice that, but you want to use the scatter chart with the lines, the scatter chart with the straight line. The scatter chart with straight line, one, it will help us to determine. That one will be a bit serious. Let's not use that. Just use the line chart. The scatter chart, you are going to use them again when you're running the correlation, that is the regression. Let's use the line chart to confirm whether there is any. You can see here that negative relationship. There's a bit of relationship, but this relationship shows that when the score of music is down, the score of mathematics is up. When this one is up here, this is one is down here. And there's that negative relationship between the two variables. If you are to create using a scatter chart, which you did, then the scatter chart with the line, best line of fit, the problem with the lower version of this will not present this, that you can first set the scatter. You see how the dots are scattered. You draw a straight line, the best of fit, then first you start with the scatter diagram and this scatter chart or the scatter table. Then from there you can try get the line of fit. And the line of fit, where do you get it from? Again, you select the trend and choose the linear trend. That is in our chart. It should show us a linear trend of our chart, showing the concentration of the dots in that line chart. And once you do this, then it will show you that there is a negative relationship between our variables. That is another way in which you can check this using the chart, the line chart, or using the scatter diagram. So the correlation will help us to know the degree or the level of relationship between the variables. Is there any relationship? If there is any relationship, then you say, yes, there is a relationship. Is it a positive relationship? Then you explain. If it is positive, then you write it is positive. If it is negative, then you confirm it is negative. Once you know that there is a relationship, then the regression is done to define the relationship between the two variables. That is, one, we have independent and dependent variables. So we are going to check on this. That do you have any independent? Do you have dependent variables? And you're going to check using this data and confirm whether there is any positive and negative. So when you are checking on the regression, there's just one thing that you need to confirm. That is, you need to master in this. Let me check about this. The regression. You just the regression. That when running the regression, the simple regression, it estimates how the variable of one dependent variable can be predicted based on a dependent variable. That is, the linear equation will help us to do that. That anytime you run this regression, then first you help you to master or to get to understand how one independent variable can be compared with the dependent variable. So, like in an example of the equation we are to solve there, and we are given that particular problem to solve. How was the equation? Let me check. Let's check together how the equation was. Then you can identify which is the dependent variable, which is the dependent variable. So have it here. So if you check here, you'll find that after determining that you are supposed to determine the variable cost per unit and the total variable cost using the regression analysis, and that is first you determine. So how do you determine? You must use the y-intercept, the x-intercept, that is the equation of the straight line, so that you'll be able to determine, given those estimates, if it is 100 units, if it is 150 units, if it's 200 units. So that simply means that first you have to run the regression analysis to get the output. After getting the output, then you can now run this output and give out the argument. So you want to use a simple data set. Then from there, we can work on our data. There was data here about the month, the rainfall, number of umbrellas bought. Let me see whether I have this data. Then we can share the data together. So that data, I've not typed it. I'll type it in Excel later, but I can share another different worksheet. Those are just other examples that we just do one example. Then at your free time, you go and run those examples. Then you get to understand how you run this analysis. Just let me check what we have under the this. So I'm sharing that worksheet. So just download it. The worksheet is written regression, saved as regression. So then you get another copy in WhatsApp. Just get another copy there. Then you can open that copy. So it should be something like this. Something. So the data, it require already now some details. You can discard these details. Just need to delete the output. I've only run this output, but you can just, okay, or instead of deleting, just copy this data. That is this data at the top here. Make a new worksheet, paste your data there. You want to use that data to make or to run that regression analysis. So that is our data. So you have copied that data in a new worksheet. Then the procedure, we're going to do it now together. That procedure of running the regression analysis. And we're going to check how you can achieve the same results, and how you'll be able to interpret your results is actually the most important part of this analysis. So for this, So in that worksheet, I have the data, and this data, the big question is that, is there a relationship between the quantity sold, price, and advertisement? These are, that is there relationship between the quantity sold, that is the output, and the price and advertising, that is input. That is, in other words, can we predict the quantity sold if we know the price and advertising? That is a big question. And we are going to run this analysis and do it together. So just click on the data tab and then select data analysis. Then you'll select regression. Just select regression. Then it will ask you the input. But now here the input, you have to present which will be the Y and which will be the X. The X is supposed to display the independent variable, or the Y is supposed to present the dependent variable. The independent variable is the variable in which we base our changes. But the change in this variable will affect the dependent variable. So here, what are we predicting? The output, the quantity sold. Based on what? Based on price and advertisement. So what now we have to set as our independent variable? So you select the range Y, and this is the predictor variable. The predictor variable is called the dependent variable. The predictor variable is the dependent variable. And once you select the range of cells, we are going to select both the price, that is, you're going to use the price, that is this explanatory variable is called the independent variable. That is, on the X range, we select the independent variable, that is explanatory variable. And this column must be adjusted to each other. So that is the two values that you're going to choose to determine the value of our output. So that is, here, you select the X, and we say the X is which variable, the Y is which variable. We have already stated that that variable that contains the values that will be predicted. That is, you say here, you select from A2 up to A8. Then the X, you're going to choose the price, that is from B2 up to B8. Then the output is supposed to be displayed somewhere. So you have to choose where to display the output. This is a dialog box. So if you selected from cell A1, remember, which is also important because it will help us to identify the labels that this column represents, that the label is quantity sold. And here the label will be the price. So just choose the price. And you have to activate labels. Then our output can be presented in a cell below here. So you can set our output. That is where this output will be presented. Then you can choose the residue, which will come to see that it's going to give us a residue table out at the end. That in Excel, produce the following summary of the output, round off to 3 decimal places, always rounding off to the 3 decimal places. So, and once you finish, you just ensure that you choose this residue and you click OK. What will happen is that it's going to give us that report. Let's see that report that it has given us. The output will just be computed automatically. And from there, you'll check on the intersect, the price to set the equation of the straight line, and you'll be able to predict about the cost, that is the quantity sold in the future. So after setting this, then our next step is to do what? That you have this data, the summary, we have the regression statistics, multiple R, we have the R square. And the significance of this is that you have to use the F and the P value to know whether there is a relationship or not. So, and so you get the value, then we actually say whether this value that you get. So your values are different. Why are your values different? You probably you selected or you typed. Do you change the data? Don't change the data. Don't change this data. Just leave it the way it is. Then the dollars, don't type the dollars, just apply those dollars. They should give us two tables, the regression statistics and the ANOVA statistics. So it will give us those two tables. So now our next lesson, we are going to expound this one further. I've seen several people have said, so we'll repeat again that regression. And then finally, we'll actually try to run this. I'm going to send this copy. If you are able to go through this copy at your free time, please go and attempt that question that was in the past paper. That is question number 25 in the last sitting. And try that question. And just like the same, that is most people did today. Once you finish, you can send your results on the WhatsApp group. You can inbox, and then you send the name. You have to save under your name. So I'm sharing that copy right away. For those people who are, okay, it's not possible to share that book in this platform because the book is big. It's very big. So we cannot actually share it here. We'll share it in WhatsApp. So you download from there. So once you get the book, you can go through, especially just go through the regression analysis. Then the other tools will come to discuss later. Then once you do that, you run the question that was done in our last sitting, question 25. So today we're going to stop there. In our next class, we'll proceed with that session, that topic.